Welcome to the video on solutions to systems of linear equations. So the first two methods for finding solutions to systems of linear equations is by using substitution and elimination. So for substitution, you solve for a variable and then plug it into the other equation and use that to solve. For elimination, you multiply the equations so that you have a variable with the same coefficient but the opposite sign. So for example, in one equation they would have 3y, and in the other equation it should have negative 3y. Then you'll add the equations together, and that variable should add up to 0 so that you only have one variable left that you can solve for. If there's no solution, the system of equations is considered inconsistent. If there's one solution, you can write down your point as an x comma y or x, y, z. If there's infinite solutions, you can write a general solution where you write one or two of the other variables in terms of another variable. So for example, you could have 2z, comma, 3/2 z, comma, z. So here we have an example that says solve for x and y in the following equations. 3x plus 4y equals negative 23, and 2x equals 6y plus 2. So we'll solve this using substitution and elimination. So for substitution, we have 3x plus 4y equals negative 23, and 2x equals 6y plus 2. So we'll solve this second equation here for x by dividing both sides by 2. So now this becomes x equals 3y plus 1. So we'll take this and we'll plug it in for x in this first equation. So we're substituting it in, and that's why it's called substitution. So we have 3 times 3y plus 1 plus 4y equals negative 23. So then we can distribute this 3 to get 9y plus 3 plus 4y equals negative 23. If we combine our like terms here, we get 13y plus 3 equals negative 23. We'll subtract 3 from both sides to get 13y equals negative 26. And then when we divide both sides by 13, we get that y equals negative 2. So now that we know what y is, we can plug that in here to solve for x. So we have x equals 3 times y, which is negative 2, plus 1. So 3 times negative 2 is negative 6, plus 1 will give us negative 5. So x equals negative 5. So your answer would be negative 5, comma, negative 2. We can do that same thing using elimination. So with elimination, we have our 3x plus 4y equals negative 23. And we'll want to move our y over to the same side. So we'll subtract 6y. So we have 2x minus 6y equals 2. So let's get our x's to be the same. So our least common multiple between 3 and 2 is 6. So we'll multiply the first equation by 2 and the second one by 3. And then we need to have the opposite sign, so we'll make one of them negative. So we'll make the second one a negative 3. So our first equation, when you multiply it, you get 6x plus 8y equals negative 46. And the second one becomes negative 6x plus 18y equals a negative 6. So when we add these together, you have 6x minus 6x is 0. 8y plus 18y gives us 26y equals negative 46 minus 6 is negative 52. So we can divide both sides by 26 and get that y equals negative 2. Then we can plug that y in to one of the original equations. So we have 3x plus 4 times y, which was negative 2, equals negative 23. So 3x minus 8 equals negative 23. We'll add 8 to both sides, so we get 3x equals negative 15. And when we divide by 3, we get that x equals negative 5. So we have negative 5, negative 2. Now we'll learn about matrices. So you can solve matrices by hand or in a calculator. First, we'll learn about how to solve it with a calculator. So matrices are especially useful when you have 3 or more variables. On the IB test, you will have a maximum of 3 variables, so that's the most that you'll need to do. So when you set up a matrix, you'll put your X values in your first column, your Y values in your second, your Z in your third column, and then your answer is the last column. And then you'll solve it by entering it into the calculator, following the steps below. So you'll click second, X inverse, which is matrix, edit A, and then you'll adjust the size. So the first thing is your rows, the second is your columns. So here this is 1, 2, 3, 4 columns and 1, 2, 3 rows. So this would be 3 by 4. If you had something like this, 3, 6, 2, this would be a 3 by 1 matrix. Or if you had something like this would be a 1 by 2 matrix. So then you would enter your values in, and then once you have your matrix entered in, you'll quit out of there doing second quit, and then you will do second matrix math to find your RREF, and you'll do your RREF of your matrix. So you'll do second inverse matrix A, so that your calculator will say RREF of A. And that'll give you your identity matrix shown here, where your X, Y, and Z values will be in your final column. So we'll use our example here. So to set this up, we look at the values we have. So we have 1X, 1Y, 1Z equals 8. So 1, 1, 1, 8. Then we have 2X, 1Y, no Z equals 10. So it'd be 2, 1, 0, 10. And for our final equation, 1x, 4y, 2z equals 0. So 1, 4, 2, 0. So then you can go ahead and enter it into your calculator by following the steps to the left, and then do RREF of that matrix, and you'll find that the answer will have your identity matrix, and your final column will have your solutions. So 7.2, negative 4.4, and 5.2. So this means x equals 7.2, y equals negative 4.4, and z equals 5.2. So as a coordinate point, it would be 7.2, comma, negative 4.4, comma, 5.2. So next we have the way to solve your matrices by hand, which is through row reduction. So you manipulate your rows to solve for the identity matrix by multiplying, adding and subtracting rows, and swapping rows. So you want to get it to look like this, and your answers will be here in your final column. So we'll practice this with the example here, where it says solve the following system of equations using row reduction. So we'll turn this into a matrix. So our first equation, we have 3x, 1y, no z equals 9. Our second equation, we have 2x, 1y, 1z equals 12. And our final equation is 3x, 6y, 2z equals 8. So the first thing we'll want to do is make our first row, first column a 1. So we'll multiply row 1 times 1/3. So this will become 1, 1/3, 0, 3. And our other rows will remain the same. So once we've done the 1 that we want in the column, we'll make the other ones into zeros using our other column that's a 1. So for this, we're going to take our first row and leave it the same. For our second row, we'll have our row 2 and we'll minus 2 times row 1 because we want to subtract this 2. And our bottom row will have row 3 minus 3 times row 1. So our new second row is going to be 2 minus 2, which is 0. 1 minus 2/3, which is 1/3. 1 minus 0, which is 1. And 12 minus 6, which is 6. And our final row is going to be 3 minus 3, which is 0. 6 minus 1, which is 5. 2 minus 0, which is 2. And 8 minus 9, which is negative 1. So now our first column looks how we want it to, so that's great. So we move on to our second column, where our middle value is going to need to be a 1. So we're going to multiply our second row by 3. So row 2 times 3. So rows 1 and 3 will stay the same. And our second row is multiplied by 3. So we have 0, 1, 3, 18. So now we're going to use that 1 to zero out the rest of the column. So we'll take row 1 minus 1/3 times row 2. And for our bottom row, we'll do row 3 minus 5 times row 2. So we'll write our row 2 first, 0, 1, 3, 18, because it's going to stay the same. So we have row 1 minus 1/3 times row 2. So this will be a 1. And then 1/3 minus 1/3 is 0. 0 minus 1 is negative 1. 3 minus 6 is negative 3. And then our bottom row, row 3 minus 5 times row 2, we'll have 0 minus 0 is 0. 5 minus 5 is 0. 2 minus 15 is negative 13. And negative 1 minus 90 is negative 91. So now our second column is how we want it to be. So we'll work on our third column. So we need our bottom row in our third column to be a 1. So we'll take row 3 times negative 1 over 13. So rows 1 and 2 will stay the same. 0, 1, 3, 18. And then we'll have 0, 0, negative 13 times negative 1/13 is 1. And negative 91 times negative 1 over 13 is a positive 7. So now we have the ones where we need them, and we need to zero out the rest of our third column. So we'll use our third row to zero out the first and second rows. So we'll do row 1 plus row 3, and we'll do row 2 minus 3 times row 3. And row 3 is going to stay the same. So we have 1 plus 0 is 1, 0 plus 0 is 0, negative 1 plus 1 is 0, negative 3 plus 7 is 4. And then row 2 minus 3 times row 3, 0 minus 0 is 0, 1 minus 0 is 1, 3 minus 3 is 0, and then 18 minus 21 is negative 3. So now we have our identity matrix and then our solutions. So x is going to equal 4, y will equal negative 3, and z equals 7. So our coordinate would be 4, negative 3, 7. So here we have our first IB practice question. It says, show that the following equations have an infinite number of solutions, then find the general solution. So it's a no calculator problem, and there are 3 variables. So we're going to want to use row reduction. So we'll set up our matrix. Our first equation, we have 0x, 1y, 4z, and the answer is 3. Our second equation, we have negative 2x, 1y, negative 6z, and the answer is negative 1. And our third row, we have 2x, no y, 10z, and the answer is 1. So we want to have a 1 in this first position. So we're going to start by just swapping our first and third rows just so that we have a number in our first position. And the reason I chose the third row is because there's a 0 in the second spot, so that'll be nice that there's already a 0. So we have 2, 0, 10, 1, negative 2, 1, negative 6, negative 1, 0, 1, 4, 3. Now we'll multiply row 1 by 1/2. So that becomes 1, 0, 5, 1/2. Negative 2, 1, negative 6, negative 1, 0, 1, 4, 3. So we have a 1 in row 1, column 1. So now we'll zero out these two. The third row already has a 0, so we'll just take our row 2 plus 2 row 1, because we want negative 2 plus 2. So we'll do plus 2. So now we have 1, 0, 5, 1/2. And then for row 2, we'll have 0. 1 plus 0 is 1. Negative 6 plus 2 times 5, so negative 6 plus 10 is 4. Negative 1 plus 2 times 1/2 is going to be 0. And then our third row is still 0, 1, 4, and 3. So now we need to take this 1 in the second column, third row, and turn that into a 0. So to simplify, we're going to take row 2 minus row 3. So we have 1, 0, 5, 1/2. And then we have 0, 1, 4, 0. And then 0 minus 0 is 0. 1 minus 1 is 0. 4 minus 4 is 0. 3 minus 0 is 3. We can simplify the third row by multiplying it by 1/3. So we'll have row 3 times 1/3. So 1, 0, 5, 1/2. 0, 1, 4, 0. 0, 0, 0, 1. We can also adjust this first row by taking row 1 minus 1/2 row 3. That way we can turn this into a 0. So we have row 1, 1 minus half of 0, so 1, 0 minus 0, 5 minus 0. And then 1/2 minus half of 1, which is 1/2, so this would be 0. And then the other rows will keep the same. So now we have all 1s and 0s except for right here in our z column because we can't get a 1 here. So this means that there's going to be an infinite number of solutions. So we'll convert each of these into an equation. So this is our x, y, z, and solutions. So we have x plus 5z equals 0. Then we have y plus 4z equals 0. And for this last one, we don't have any variables left. So we can solve these equations for x and y. So we have x equals negative 5z and y equals negative 4z. So x equals negative 5z, y equals negative 4z, and z equals itself, so z. So this would be your general solution. You could also write it as a coordinate of negative 5z, comma, negative 4z, comma, z. So you can put in any value for z, and your system of equations will still be true. And that's why there's an infinite number of solutions. So here we have our second IB practice question, which is also no calculator. It says find the values of a and b where the system of equations will have no solution, one solution, and infinite solutions. So let's start by converting this into a matrix. So for our matrix, we have 1x, 1y, 4z equals 3, 3x, 2y, 1z equals 6, 1x, 3y, a minus 1z equals b minus 2. So we'll start with some row reduction. We have a 1 in our first row, first column. So we're going to use that to make these other values 0. So we'll have row 2 minus 3 times row 1 and row 3 minus row 1. So our row 1 is staying the same, our 1, 1, 4, 3. Then row 2, we'll have that minus 3 times row 1. So we have 0, 2 minus 3 times 1 is negative 1. 1 minus 3 times 4 is going to be 1 minus 12, which is negative 11. And then 6 minus 3 times 3 is 6 minus 9, which is negative 3. And then for this final row, we have row 3 minus row 1. So 1 minus 1 is 0, 3 minus 1 is 2. A minus 1 minus 4 is going to be a minus 5. And then b minus 2 minus 3 is going to be b minus 5. So now we'll work on our second column. So we need this value to be 1, so we'll multiply row 2 by negative 1. So row 1 is the same. Row 2 is going to be multiplied by negative 1, so we have 0, 1, 11, 3. And then row 3 will stay the same. And now we'll use row 2 to zero out these values. So we'll go up here. So we need to do row 1 minus row 2. And then for row 3, we need row 3 minus 2 times row 2. So we have 1 minus 0 is 1, 1 minus 1 is 0, 4 minus 11 will give us negative 7, 3 minus 3 will give us 0. Row 2 stays the same, 0, 1, 11, 3. And then row 3, we're taking away 2 times row 1. So 0 minus 0 is 0. 2 minus 2 is 0. A minus 5 minus 2 times 11 is a minus 5 minus 22. So this will become a minus 27. And then b minus 5 minus 6 will be b minus 11. So part A is where there's no solution. So we'll have no solution if our a minus 27 equals 0 and our b minus 11 does not equal 0. So if a is 27 and b does not equal 11, then we'll have no solution. Because our resulting final row would say that 0 equals some number, if b is some number other than 11, and that can't be true, so that would be no solution. For b, we want one solution. So we'll have one solution if a equals anything but 27. So as long as a doesn't equal 27, and b just has to be any number. So b is any real number. So that's where you would have one solution. And then we'll have infinite solutions if our a minus 27 equals 0 and our b minus 11 equals 0. Because this means that z could be any value, so we'll have infinite solutions. So if a is 27 and b is 11, then we'll have infinite solutions. So if a is 27 and b is 11, if we have infinite solutions, then our matrix would become 1, 0, negative 7, 0, 0, 1, 11, 3, 0, 0, a minus 27, so 0, and then b minus 11, which is 0. So this would mean x minus 7z equals 0. And for the second row, we have that y plus 11z equals 3. So y equals negative 11z plus 3. And then z is our free variable. This means that our general solution, our x, y, z, would be 7z equals negative 11z plus 3 equals z. Or as a coordinate, 7z, comma, negative 11z plus 3, comma, z. So that's just your general solution if it were to have an infinite number of solutions. So in summary, systems of equations can be solved with substitution, eliminations, matrices in a calculator, or matrix row reduction. So if you use substitution, you'll solve for one variable and then plug it in to the other equation. For elimination, you'll multiply your equations so that you have opposite but equal coefficients for one variable, and then you'll add your equations together to eliminate one variable and solve for the other. For matrices in a calculator, you'll convert your equations to a matrix and then enter it into the calculator and use rref to do our matrix row reduction in the calculator and get your final answer. And finally, for matrix row reduction, you'll simplify to the identity matrix, as shown in this bottom corner, by adding or subtracting rows, multiplying by constants, and swapping rows. Finally, your system of linear equations can have no solution, in which case it's called inconsistent. It can have one solution, or it can have an infinite number of solutions. That's all for this video. Thank you for watching.